You can't win them all.
Oh my god, wait, literally? I love it. Because it
No,
doesn't taste
she actually loves it figuratively.
Stop. It tastes like Earl Grey, but with like a good smell.
Really?
Yeah. I mean,
Oh,
maybe
it's
you
a
just forgot what
stupid
Earl
Earl
Grey
Grey.
tastes
It's not
like.
open.
But, whoa.
They was
You
almost.
did not.
No, they
Tastes
almost
You
took a
absolutely
sip.
did not.
No,
But I mean, it is fine. It was like right there.
Okay, would somebody join to see if I am presenting or not?
Whoa,
Oh, I got it on my phone.
Griffin got it.
I need a little dip. A little dip.
Too much
Griffin
is
knows
on my chip.
Well, what are you gonna use to start with the sheet?
I'm just gonna shake it.
Shake it.
Shake and bake,
Shake
you
it.
know?
Shake
Like
it.
it.
Like this.
Load.
Hey, we're all man here.
Is it?
We're all man here.
Oh. Oh no, that was good.
It's so spicy.
It's because I can't see where the liquid is, so I like shook it and I was like, oh, that's really gross to watch.
Man, it's loading. It's being stupid.
Oh, yes.
Join.
Oh my god, it smells so good. 10 out of 10 from me.
This is some.
Activate.
What did you get?
Okay.
Andrew, do you see you on the Instagram?
Oh, no,
You are presenting.
Okay, you can see this?
Yeah.
Okay, thank you. You don't have to stay.
You know how to do that?
No.
Oh.
All right, are you guys ready?
Yes, coach.
Coach.
Math coach.
That's right.
Yes, sir.
No.
Are we ready?
Wait, I don't know which one Zoom it is. Oh, there it is.
What?
Yeah.
Boo.
I was like, why do I hear something on my screen?
The second mic.
The second like?
Yeah, there's only one mic.
I just look at it.
Are we ready? Okay,
Can you get off that? Do you need Marvel to stay on?
no.
Okay, then get off.
All right, so we talked,
Smoothie.
we talked last time about how to find a tangent line. So if I wanted to find a tangent line through some point, you take it until it just touches the one point, right? And then that would be the point at which you basically find the slope, the instantaneous rate of change at that point, using the derivative. Well, that's not distracting at all.
Choice time.
So for this, remember we got the slope was that was not responsive.
Whoa.
Smells smoky.
Yeah, the slope.
Right, so you plugged everything into y equals mx plus b.
Yeah, let's say this is A, right? This would be f prime at A.
I like it.
So you take the derivative, you plug in the number, and you get the slope at that point, right?
Wait, who is it? I'm commenting.
Are you guys following?
I am.
So your slope or your function of the tangent line will be y equals, the slope is f prime at A.
I'm just gonna add you with this. I'm just gonna add you.
I vote for the next.
You do?
Yeah.
Wow.
Pay attention, please, guys.
You just voted today?
Will,
But my secrets are my own. So I just said them.
quiet, please.
Guys.
Are we okay so far?
Yeah.
All right, then you just plug in your point. X is A, right? Y is f of A. And then you solve for B to get your equation of the tangent line. That's all we needed was B. If I rearrange this, you'll see that B has to be equal to f of A minus A times the derivative of f at A. Does that make sense?
Yeah. I'm gonna write this down though, so don't get rid of it.
So that means if I rewrite that using what I know b to b. The equation of the tangent line will be y is equal to the derivative evaluated at the point for the slope.
Jeez, says we gotta use on the test.
And then we're going to add b, which is plus f of a minus a f prime of a. I just plugged in b was. And the only other step I would do is just to clean that up to have fewer terms. Is I see that these terms both have a factor of f prime of a. So I'll just factor that out. F prime of a. And we have a term that has an x and a term that has a minus a. And then we can write plus f of a.
What is the arrow to, like, what's the arrow from?
I just rewrote the equation of the line, but now I plugged in what b was, where before it was unknown. So that would be your formula for the equation of a tangent line at the point A, where your function is f.
Wait, so the last equation is the one that we plugged stuff in?
Yeah. So if you memorize this, these problems will go very quickly. If you don't, I mean, you can just find the derivative to get the slope. You plug in the point like we did last class. You'll just work it out, and you should get this anyway.
Wait, so for this kind of problem, what do we need to find?
This.
Right, so when we did it in practice, we had, like our derivative line, and then
But you
whatever
want us
point
to
we
graph
want
it?
to tangent it.
Yeah. Yeah, you probably have to graph it, yeah.
Like to draw it out on the test too?
Yeah.
Resting.
Huh?
Pull port.
And
Pulled pork.
Oh, that sounds
It's
good.
such a weird one.
It's a weird lunch.
Sounds good.
We
though.
never eat red steak and pork pork. That's so
Sounds really good.
It's
Like
a,
everything on its own sounds good.
yeah.
I'm hungry.
All right. Are you good?
Yeah, okay. I
Great.
think
Alright.
I know how to do this. It's just kind of weird to like look at it without numbers, like when you just have the
Yeah.
like letters in. But I think I get it.
All right.
I don't know what that means.
All right. Intermediate value theorem is a very easy one. It's very simple.
What,
It-
what is
What's
it?
tangent line?
Intermediate value theorem.
Thank you, Griffin.
It basically says that, let's say at some point, I'll say here,
IPT?
and at some other point here, the y value, the value of the function at these points, they have two different values here, right? It basically says that, I'll just do this, I guess.
You got way too much.
All right, basically any value between the value here and the value here, if you have a continuous function, the function must pass through every intermediate value as it goes from this value to that value. All the intermediate values get reached, right?
I mean, that makes sense. Like,
Yeah.
It just makes sense.
Makes sense.
Now it can,
Whoa.
Whoa.
Don't do that.
Going crazy.
Whoa.
No,
What?
Oh my.
Oh, but it still goes
Wait, so
through
does
every
it still
value.
count
Yeah, so
if you
it-
do the, because like, obviously it's not like the function test because it passes.
No, it's not, fine.
right, so now it still goes through every intermediate value, but it can do some more than once. But at least does it once.
Should I draw that one? No, he's literally poured out so much. He's done it like 7 times.
Is that
I'm
sugar?
concerned.
Adrian's watching. It's sugar cane.
Does that make sense?
Yeah.
So sugar.
Do you want us to find
That one's just a simple one. It just means that if the function was at 3 and then it's at 5, it had to have gone through 4 at some point.
Right.
If it's a continuous function. That one, there's not much to that one.
That's not your teeth, that's ours.
This is not quite.
That's our wall.
My 2 is supreme no cat. Like, this is excellent.
That's not your teeth, that's
All right.
Oh, so that's, like, we don't need an equation for that.
Yeah, that one's just like a basic concept.
So we just need to know that from 3 to 5,
a lot of times people will be like, based on the intermediate value theorem, we know that this has to be true.
Oh,
So when they say that, just know what they're talking about.
okay, so what's the M?
Multi.
Mean.
variable.
What is it?
Mean,
Mean.
Oh.
Wait, what does I stand for?
intermediate.
Wow.
All right.
No?
No.
What are we supposed to?
Yes.
All right, so intermediate value theorem, I'm sorry, mean value theorem says that if you have 2 points, let's say you have 2 points, right,
Yeah.
on this function. The mean value theorem basically says that, I hate this. That's close enough. All right, do you see how this is like the line that connects those 2 points?
Right.
That line has a slope. That's the average rate of change of the function in that interval. There is some point on the function that has that slope. So sometimes they want you to find that
Oh,
point.
so like the tangent point for that? Or no?
All of a sudden, they want you to find the point that
Yeah.
has that same tangent on it.
Right.
Yeah, like this is a secant line, and somewhere there's a point where that becomes a tangent line. What point does that? That's what the questions will be.
Oh,
We're
How are you
doing
gonna do that?
some focus over there.
I'm gonna text you.
Well,
You need a hero.
no, don't do that. Pay attention.
No, he Andrew Velasquez was not.
I know, I didn't.
No,
Oh, Andrew
no.
Rose.
No, you just meant.
I mean, I could have his number. I
Right,
could.
right.
I could if I wanted to.
Are you listening?
I am listening.
All right, so for this one, for the mean value theorem,
You should try to get-
the way you would find that is you have a point f, let's say this is a, x equals a, and this is b, right?
Okay.
So what's the slope?
Oh, it'd be the change of A over the change of, or wait, is it change of A over change of B, or is it like change of A?
It's the function at b minus the function at a, that's the rise,
Okay.
Divide.
the x values.
Oh, yeah. Oh,
Okay.
yeah. One.
Rise over run, right?
Yeah.
So what would you put for?
Because this point
What would
would be a comma f of a.
Yeah.
And this point would be b comma f of b.
Like,
We'll figure out that F is one.
yeah, I think so.
So like what?
In algebra 2, SJ, I taught that people that like over and over again. And then I see them this year and they're like, what does that mean when you have an f of something? I'm just like, God.
Okay, so it's the y values over the, how do you know that it's,
Rise over run, slope.
how do you know that it's B minus A instead of A minus B?
It technically doesn't matter as long as you're consistent on top and bottom.
Okay.
But we normally read functions as going left to right on the graph. And especially if this represented time and you wanted the change, you normally think of the change as being the new value on the right minus the old value on the left.
Okay.
Because this is a ratio, it doesn't matter. So I don't have to do it that way technically in this case, but it's a force of habit, I guess. You just have to be consistent though.
Yeah.
So that's how you find the slope, right? So all you're gonna have to do is find the slope of that line that crosses through those 2 points, and you're gonna set that equal, you're gonna make an equation. You're gonna set that equal to the derivative of the function.
Function we used to find take the line.
No, the function, this function. You're given a function, right?
Yeah.
And we ask you to find the point where the function's derivative equals the average rate of change between x equals a and x equals b. So you find the average rate of change. That's the slope of the line that crosses through. That's this, rise over run.
Yeah.
And then you take the derivative of the function, which will then give you the slope at any given point. And then you set that equal to the slope that you calculated, and you solve for x and you find the specific x. So this would be x naught. That's the specific x that makes the derivative equal that slope. Easy?
Maybe.
If it looks right.
It's so right.
I mean, does that make sense?
Yeah, I think so.
That makes sense.
Goes.
The derivative can tell you the slope at any given point. We want to know when does the derivative equal a particular value. So you just take the derivative, set it equal to a number, and solve for the x that makes it true.
So this is
How do we solve for that?
What's that?
How do we solve for that?
You just solve for x.
You got me there.
They get you there. He does have a point.
This tea's pretty interesting.
What did you want?
The brown.
So like let's say you had the parabola x squared.
Yeah.
Okay.
All right, so let's say we're going from -1 to 5.
Write that down as an example.
All right.
You need an example.
I'm confused. I want
Uh,
to see how it's done.
Yeah.
I want to see the master.
master.
I want to see master Satella.
Watching them.
All right,
Chief.
I want to see
Oh,
master.
he does presentations.
Master Yi.
But they're,
Master E is sick.
What class is that?
I played Master E
okay,
yesterday.
wait,
Did you?
Until we did. Until CC.
Yeah, I mean, that's how
All right, here's my function, right?
Yeah.
We want to know from the values between x equals -1 and x equals,
Okay, so
Um,
you will give us the 2 point, right?
let's say 4.
2 dot.
Yep, that's right here.
oh, 4?
-1 and 4. We want to know,
No, you just said.
we want to find the x value that has the same, where the function's derivative equals the rate of change between, the average rate of change between these 2 points for the function.
Okay.
So I'm just going to take f of 4 minus f of -1 all over 4 minus -1. That'll be, well, we plug in 4, right?
Minus
What does that give me?
plus 1. 15 over 5. Is that right?
Yeah, it would be 15 over 5.
Which one?
What is that?
3.
Good. So that's the slope.
Yeah.
We're now going to set 3 equal to the derivative. And I'm just going to put a little mark on x just to show that it's not a variable. I'm looking for a specific x. What's that?
Plug the x into the equation and then
Well, take the derivative, right? What's the derivative? 2x. And then I solve for x.
No, I'm saying like, how do you get 15 on top?
we plug x. Do you see the equation on the top? Like that's 4 minus
Oh,
that.
I'm like, how'd you get that? That makes so much
I
more
don't think I
sense.
do know how you got it.
You said
so I-
above.
4 square minus 2
Right. Oh,
minus.
that makes sense.
Yeah, that's what I'm
Yeah,
saying.
it
I was
goes
like,
one
where did
minus
you get
two.
this at?
No, duh. Okay, yeah, that makes sense.
I was so confused for a second.
I was so busy being proud of Will getting it so quick that I didn't bother to ask if I got it.
Same.
So 1.5?
So for this
3
kind of
halves,
function,
yeah.
you'll give us the equation and then
The function
red.
Yeah.
Oh yeah. That's all I got.
and the 2 points.
Yeah.
The interval, yeah. I might give it like,
1x, 1y.
yeah, I know I might be like on the interval -1, comma 4.
Wait. Wait, if you go down, I need to.
Wait, what?
I might say,
Wouldn't that
Fu-
be
hold on, one question at a time, please. If I give you a function, I might say find the point where the derivative equals the average rate of change on the interval -1 to 4. That's the same as saying from x -1 to x4. Okay? What was your question, Nate?
You scroll down.
Yeah.
It smells like it should taste like a cinnamon roll, and it doesn't taste like a cinnamon roll, so it gets it.
Like, it smells like a cinnamon roll, but it tastes like biscuits and gravy.
It tastes like
How
a
do you-
pot.
how do you solve for 3 equal? Oh wait.
Caramel
Yeah.
apple sugar.
Yeah.
That's the equation we're going to solve. because we want to find where the derivative equals that slope. Are we good?
Yeah.
Questions?
Sugar.
Are we okay?
Need more
Yeah.
Okay, this one is almost exactly like the last one. It's actually
Wait, what's the name of this?
the mean value theorem.
MVT?
Yeah.
Yeah,
What's the same one?
mean.
MVT.
Oh, no, I meant the next one.
Most valuable.
Rolle's theorem
Oh,
is a
Most valuable tank.
Rolle's theorem is pretty much the same thing.
okay.
It's just the special case where the 2 points at which you the x equals a and the x equals b, when those 2 points have the same output for the function,
Why did this not work?
What's the name for this?
Rolle's theorem, that means the rate of change is going to be 0,
Okay.
right? So that means you're looking for where the derivative is 0. Otherwise, it's the exact same thing.
Right.
Except you don't have to calculate the slope there because you know you're setting the slope equal to 0. So you just kind of skip that step. You're just going to say f prime. Oops. Of x naught. Right?
So f prime x naught.
And then you solve that for x.
Gotcha.
It says 0.
Yeah.
What's this one called?
So you,
Roll.
for this one, you'll give us like 2 point and then a function too.
Yeah.
So pretty much
The same as that one.
It's the same as the last one. It's just a special case when these 2 points are at the same height, like vertical point.
How cool would it have been to have a theory named after you for doing the most basic thing?
Yeah. This is a whole
Like
class.
back then, right, before they had everything written down, you could just be like, yes, I've discovered that the slope of 0 at one point is equal to the slope of 0 at another point.
Yeah. The Atwood machine? Do you know what that is?
Uh-huh.
I'll show you.
So you pretty much should. That's dumb.
What's that?
Is this the right thing? I don't know if I'm thinking of the right one.
Atwood.
Yeah, the Atwood machine.
Is it just a
What does
pulley?
it do?
It's a single pulley with like one thread.
Whoa.
That's the person.
And now it's named after him.
It's a machine that can balance a certain amount of weight with the exact same amount of weight. Thank you, Mr. Atwood,
Really?
for your genius.
Oh yeah. Such an iconic picture. Legendary.
I built a machine. It's called a
Look, I have a
bar.
thread and I have a pulley.
Yeah. Literally just putting a rope on a bar. Right? Not exactly. I guess a pulley's a little different. This like a simple pulley says that. All right, we're gonna save the last one to the end because it is more complicated
Oh no.
and much more involved. I need to make space.
Oh, that's a lot of space.
So good.
Maybe a
So we're
little,
gonna do this one after.
maybe a little bit more.
We're doing
Oh,
actual.
I
He
can't.
just keeps moving it.
We got 5 minutes. Is this gonna take 5 minutes?
This is gonna take 7 hours.
This will take more time than 5
To
minutes.
understand PBT. What does it stand for?
Extreme.
Oh
Oh,
no. You already know.
Oh, that's extreme. Oh my. I really don't like this.
Oh, I feel like I should be eating a cinnamon roll. It's really not.
Like I crave.
I need some tasty little sweets.
I know it's telling me that this.
How does someone already got the picture that we
All
took?
tea does is
What?
How does someone already got the picture that we took? Second hour.
Wait, let me see.
That was only for seniors.
Yeah, I know. Like someone already got.
Next.
Oh, that sugar didn't mix it.
good. Yeah. It was really weird. It was so much warmer than I was used to. It was weird. It was really easy though. Tomorrow's regional.
Oh, that was reasonable?
Tomorrow.
Oh, it's mine.
Oh, you're doing what?
It was going easy, but it was still not fun.
Rest in peace, my son.
You don't think you're getting
Rest in peace, said you wanted.
Okay.
That's me, too.
Yeah, plenty of it, too, 'cause I use it.
You might have made a slight mistake.
Slightly mistake. Big change.
Or,
Yeah, when I saw it, I was just like, oh my god, this is heavy.
not big, it's
Nice.
Oil is dropped.
So sneaky.
See, all this oil. It's so much aluminum foil.
Are you kidding me?
Why is there so much aluminum foil?
Why would there not be
Oil
aluminum foil and plastic wrap?
Okay.
Can I go to rinse this?
No.
Bottle painted over.
Well, if you leave it,
Orange still might
if
be.
you leave it dirty, it doesn't flavor. If you leave it dirty, the flavor will be stronger. If you leave it dirty, the flavor will be stronger. That's like what they do in France with pans. They don't clean pans in France. Because then everything becomes flavored.
You don't think what?
Pans,
Unless you legit can't feel the taste.
Yeah.
yeah.
But
Right. But they won't like wash it or use soap or anything because they're like, everything is flavored.
Yeah, there's gonna be a new legend that
you
gives
don't
you
think it.
armor carriers magic.
But some fans you
So there's gonna be 4 of them now, in that one?
all steel.
Right, probably.
That's dumb.
I only know that the French do it because I
That would be
watch
so
Emily in
good on like
Paris.
Carthus, on Kazakhs, on Jugglers.
But then I'm big.
How do you really do it?
What? What's
How
that?
are you doing?
Oh,
I'm doing.
Marvel's living, I am alive.
Guess I'll stop the recording.
No, Bella needs this.
Yeah, Bella needs to know about how we're doing.
Are you taking her to lunch even though she's not there?
She's definitely doing it.
Just take the recording. She's like, yeah, so.
Oh my god, she can watch it back.
Yeah.
Oh, that's bigger than breadsticks.
Breadsticks with pulled pork and macaroni and cheese. What a weird one.
I don't like the new layout.
All right.
All items are broken, none of them are broken.
That's true. And all the items that were